This is the Six Sigma presentation for Group 4 on how to improve the process of making coffee. Our group decided to analyze the process of making 2 servings of coffee. Participating in this process are Abdullah, Chris, Kalfan, Morgan, and Pravesh. We have selected this process because it is one that is performed millions of times every day and could provide a benefit to many people. During the course of the semester, we performed several timed experiments to better understand how the process can be improved. In this presentation, we will discuss our initial findings, areas we targeted for improvement, and benefits we observed from our changes. The first parts we analyzed were the various components involved with brewing coffee. Using the SIPOC diagram, we were able to separate the various components needed to complete the brewing process. The diagram splits the procedure into suppliers, inputs, process, outputs, and customers. The key suppliers included the market where the coffee grounds were purchased and the utility companies that provided water and drainage, as well as the electricity that powered the appliances. The utility companies were essential to the home brewing process and could not be changed in any practical manner. However, there was an opportunity to select a different supermarket where the coffee grounds were purchased. Both travel distance and price variations were areas where improvements from the current state could be seen. Next, we focused on the inputs needed to brew coffee. The basic inputs required for the coffee were coffee grounds, coffee maker, electricity, water, a filter, coffee mug, the individual making the coffee, and time needed to complete the task. After identifying the inputs, we tracked the steps needed for the process to be completed. On the slide, you can see the 23 steps we observed, going from purchasing the coffee through washing the mug after the coffee is consumed. After tracking the process, we were able to more easily identify the outputs from the brewing process. The most obvious output was the 2 servings of coffee. We also realized waste and pollutants were created, such as coffee grounds and emission of steam. Finally, we established the primary customers, mainly the individual drinking the coffee, as well as anyone who may want the used coffee grounds for composting. The next part of our analysis was creating a value stream map to better identify the time spent on the brewing process. We observed the steps needed to make the 2 servings and noted the time spent adding value as well as dead time. The total observed time was 12 minutes 38 seconds. This included dead time of 44 seconds, which resulted in a value adding time of 11 minutes 54 seconds. At the bottom of the sheet, you can see the legend which represents the various symbols used in the map. The value map is split into 3 phases, the first of which is turning on the coffee maker. The second phase involved allowing the coffee to brew, which took approximately 7 minutes 28 seconds, or about 58% of the total time. The final phase involved the serving and cleanup process, which included pouring and tailoring the coffee to one's own tastes. We also included turning off the coffee maker, removing the waste, and cleaning the pot. The value stream map allowed us to better identify areas we could target for further improvement. Decreasing the overall time spent was the ultimate goal, as well as reducing the amount of wasteful dead time. Another method we used to track the brewing process was through a formal observation sheet. This observation sheet was more structured and gave us specific items to monitor during the brewing process. A blueprint of the work area is also provided for better visualization. Essentially, the observation sheet is a cleaner, more concise version of the value stream map. The time spent is listed on the leftmost column, making it easy to identify where a relatively large amount of time is spent on each process. Next, we moved on to an A3 problem-solving sheet. This sheet forces the user to articulate all the necessary process information into one space. This ensures the user is concise in their descriptions, so as to reduce the amount of excess information and generally get to the core of the problem. The sheet is split into the current and future states of the problem on the left and right respectively. For the current state, we recreated the value stream map. This allows a user who is not aware of the problem to easily grasp the situation. Under the value stream map, we established feasible goals to improve the overall process. In the case of brewing coffee, first and foremost, we are aiming to reduce time spent. Then we focused on reducing overall waste, or else finding a process which may benefit from the waste created. The final goal was to find a way to make better use of the considerable time spent actually brewing the coffee. For the future state, we thought of ideas which could help fulfill the goals identified in the previous step. First, we researched a different coffee ground, which results in less overall waste and may be brewed faster. Next, we looked for a process which reduced the cleanup time required after the coffee was brewed and poured. The future state then breaks down into an implementation plan, costs associated, and potential benefits for the new procedure. We decided to explore a potentially more effective plan which used instant coffee rather than ground coffee beans. In order to measure effectiveness, we brewed a second set of coffee using the revised implementation plan. In the end, we realized a cost benefit of $4 and were able to produce less waste as well as achieving the ultimate goal of reducing overall time spent. The final step was a follow-up which included updating the SIPOC and value stream map. This would allow for better documentation and ease of comparison between the original process and the improved process. This revised SIPOC diagram details the components used in the improved process. We ended up with a reduced amount of steps in the overall process because we were able to consolidate some steps together, resulting in less overall time invested. The suppliers and inputs remain the same, with the exception of switching from coffee grounds to instant coffee in the inputs. This then reduced the customers to one, that being the individual consuming the coffee, since spent coffee grounds were no longer a factor. The future value stream map clearly shows a significant improvement in our overall time and value-adding steps. We effectively reduced our total time and dead time, resulting in an improvement of 4 minutes 37 seconds, or a 37% decrease in time spent. We also created a method which required 2 main phases instead of the original 3 by rearranging the process. Process improvement is divided into pros and cons. Pros included much less overall wait time, less steps and thus less effort, as well as less waste from filters and coffee grounds. Cons included slightly different taste, as well as an increased cost. While analyzing costs involved, we found the original process cost about $11.19 for 40 servings, while the revised process cost $18.20 for the same number of servings, using Nescafe brand instant coffee. Despite the increase in cost, the overall goal of less time spent was achieved. In conclusion, we managed to significantly decrease the time spent on the process of brewing coffee by changing a number of simple inputs and methods. However, the final customer should always be consulted in regards to the slight change in taste and increase in cost before implementing any of these changes. We now open the floor to any questions or comments by the audience.